I chose a problem out of Crossing the River with Dogs, a second edition. This problem can be found on page 22. It's number 8. The title is A Whole Lot of Shaking Going On. And the problem is this. If 6 people met at a party and all shook hands with one another, how many handshakes would be exchanged? So, in order to exercise George Polya's mathematical problem-solving process, I know that the first thing I need to do is understand this question. Like, what exactly is it asking me to do? And what aspects of it are important? So, I know that the fact that there are 6 people at this party is important. I know that they all need to shake hands with one another. And I also know that the ultimate goal, the thing that this question is asking me to solve is how many handshakes need to be exchanged in order to ensure that that happens, to ensure that all 6 people do in fact shake hands with each other. So I think that the easiest way to go about doing this is to draw a picture. And I'm going to draw a picture of 6 people present at the party. The people will be represented by circles. And I'm actually going to go about this from a point of view where each person is responsible for initiating the handshake. I think that this will better organize the data and make it a little bit easier to keep track of who has and who has not shaken hands thus far in the party. So this person is going to be our particularly outgoing individual, because we're going to be working from the left to right. And they're going to initiate a handshake with all other people at the party except for themselves. So that makes 1, 2, 3, 4, and 5. So this individual shaking the hands of 5 other people, initiating handshakes with 5 other individuals. What's important to note here is this person doesn't need to go back and reshake this person's hand. They've already exchanged one, no need to go backwards. We're only shaking the hands of people to the right. So they're going to go over to 1, 2, 3, and 4. Same is true here. We've already been approached by both of these people for handshakes. We only need to go to the right. 1, 2, and 3. It's at this point, at the third one, that you can tell that the pattern of 1 less is consistent. This is due to the left to right initiating pattern. So it's safe to say that this person is only going to need to approach 2. This person, only 1. This person's feeling a little shy tonight. Maybe they're just letting the party come to them. And they didn't initiate any handshake, but they were approached by every other person at the party. So what we can do now is take these numbers and add them together to find the total number of handshakes that are exchanged at this party. So I know that 5 plus 4 is 9. And 2 and 1 are 3. 3 plus 3 is 6. 9 plus 6 is 15. So that makes 15 handshakes would need to be exchanged in order for all 6 people to shake hands with one another. I think that this strategy was quite effective. I think that if possible, creating some sort of visual representation of the data or the problem can be very helpful, whether it be in a picture, a chart, or a graph. And I think that taking the approach of having the initiators of the handshake was helpful to keep it organized, and also a little bit more manageable as far as what exactly was going on. If I were to do this problem again, I would probably do it the same way. Visual style learning is is one of my strong learning styles. So thank you very much for watching the video, and I look forward to getting feedback.